This is the equation for sine x plus y. Let us decode this equation in a geometric way. Let us first take a unit circle and let us draw a right triangle with angle x plus y. Now, since the hypotenuse is of unit length, the opposite side is equal to sine x plus y and the adjacent side has a magnitude equal to cos x plus y. We will now draw two triangles with angles x and y and stack them one on top of each other, such that the total angle subtended is still x plus y, and since hypotenuse is again of magnitude 1, the opposite sides are sine y and sine x, and the adjacent sides are cos y and cos x respectively. The geometrical proof will follow a process of resizing the two sine components and fitting them exactly inside the sine x plus y line. We will start with the sine component of the lower triangle. When it is moved to the vertex of sine y side, it will be resized. To calculate by how much, we would have to consider these two similar triangles, in which the ratio of the hypotenuses 1 is to cos y. Then the ratio of the opposite sides must be sine x is to sine x times cos y. Hence, the sine x component will be resized to sine x cos y. Then, we will consider the sine y component of the upper triangle, which is slanted at an angle, but we want its vertical component to fit into the sine x plus y side. We construct a triangle with sine y as the hypotenuse. And to find this angle, we will start with the angle of base triangle. Since these two are alternate angles, they must be equal, and this angle is 90 minus x, hence, the required angle is x. Now, since the vertical component is cos x part of sine y side, we get the length of the vertical component to be cos x times sine y. Finally, we have to move the sine x cos y component horizontally without resizing it, so that the vertices of the two components meet, and they exactly fit inside the sine x plus y side. Hence, proving the sine x plus y equation.